Mr. Rich Martin is the International Business Manager of Recreational Water Programs for NSF International. Mr. Martin has attained his bachelor's in Science of Human Physiology along with pre-med from Michigan State University in 1993. He's been in the industry and worked for 18 years with NSF with different responsibilities in management. He has attained multiple pool and spa operator training certificates, NRPA, AFO, APSB, NSPF certificates. Richard interacts directly with clients and his fellow NSF staff. He presents both technical and business-oriented seminars, as well as technical symposiums to manufacturers, regulatory agencies, public health officials throughout North America. I've personally known Rich since 2003, and I work for a commercial swimming pool manufacturer, so you know how our relationship is. All kidding aside, Rich is has incredible work ethic. He's as kind as he is knowledgeable, and it's a pleasure for me to present him. So, introduce Rich.
Troy, thank you very kindly for all that smoke. I appreciate it.
All
right. Ladies and gentlemen, thank you for being here today. I definitely will not be able to hold a candle to Mr. Byron Embry in that previous presentation, but I will attempt to provide some lighthearted moments here and there for this sort of grim material. Anyway, what we're going to be doing today is just kind of doing an overview of some of the interaction between standards, code development process, and how that specifically applies in the evaluation of UV systems. So the UV systems, as you're all familiar with, are obviously used for what some people call supplemental treatment, but I actually consider it primary treatment for certain types of organisms, such as Cryptosporidium. But they also have other uses in the water treatment process, whether it's a chloramine degradation and breakdown and other processes, really just to help reduce oxidative loads and requirements. So as part of an overview, again, we'll talk about standards and the codes, and it's really why they get developed, how they get developed, and how through the process you can actually cross the stream, so to speak, and have a standard developed that can actually meet the needs of multiple markets. Beyond that, just a little bit of an overview on Standard 50, which is, again, a standard that some of you are probably familiar with. Standards are different from codes in that standards are usually developed to evaluate some product or some system or some facility, and codes get into language that relates to system construction as well as operation. So we'll just kind of touch on some of those things and how they cross over. And then some specific examples, such as the ETV protocol, which is an NSF document, and we'll get into that a little bit later. But then just, again, that concept of harmonization or getting some two birds with one stone, so to speak. And then beyond that, what the purpose for all of it was and how it benefits the different stakeholders. Then the last part of the presentation, which if you, and I'm sure you all did this, when you got your CD yesterday, you probably went right up to your room and you fired it up and you looked at all the PowerPoints for everyone and you're like, gosh, I'm ready. Well, anyway, in my PowerPoint, I don't intend to get through the entire thing, but what I did is I created a homework assignment for you. All right, not exactly. So there's basically the content I'll go over today, but there's additional information in there that gets into more of the nitty-gritty details of how one would test and evaluate UV systems for drinking water and or recreational water use. So that'll be basically slides 50 plus through 80. But anyway, without any further ado, I just frightened you with some numbers there. Yes. Anyway, so the whole concept of the standard and or the code, why are they really created? Well, obviously we're trying to have some structure. We're trying to have some coherence in the requirements to really benefit the buyers of products, the operators of the systems. So if you don't have some kind of a consistent or fair way of evaluating products, it makes it very difficult for you to make good decisions. So again, through the implementation and creation of codes and standards, you're looking for this ability to quantitatively assess products or systems, and you're hopefully getting some data that can be trusted and useful to you. So that issue of that process can be quite complex and burdensome and challenging, and some people will characterize it as Byzantine, which is kind of a pro and a con. So the concept of the standards or codes being very complex, convoluted, and difficult to understand is sometimes characterized in this term, Byzantine. Well, Byzantine isn't necessarily a bad thing because it can create some very beautiful structures, and the endpoint or the goal can be safety and protection. but sometimes it's pretty complicated and involved to get there. So you might have this concept of how was that beautiful structure built? Well, obviously there's the foreman, the person, the planner, the designer, the person that's actually supplying the materials, making sure that there's a high level of quality for the foundation blocks so the whole building doesn't crumble. But it's that type of concept that with all of these things, hopefully you can get past the issue of the bureaucratic process of looking at that as a barrier, but really the foundation to having society and structure to protect the end users and actually get a quality product in the end. All right, so my company does standards writing and testing, and so we're kind of blamed for a lot of things. But the intent is to really involve persons with the development of the codes and standards such that we can actually provide a dependable, reliable product. So really trying to do that can create market barriers to some. So it's a potential positive and a potential negative. And this concept of the paperwork and trying to deal with it, well, that's really happening at multiple levels. So if you're a manufacturer, as Troy indicated, you probably see that. You're trying to deal with these codes and standards and comply with them, and they're complex and difficult. So if there's a way to consolidate and make these things more transparent and coherent, that's to the benefit of all, the manufacturers, of course, the facility operators and users. Well, to that end, there was a study that was conducted by the American Water Works Association Research Foundation in 1985, and this is, again, for the drinking water industry. But some of the lessons there are the exact same things we're going through in the area of recreational water. So you have a problem where the individuals that are involved in all the specifications and use of products are trying to find something they can rely upon. Well, if everything is done a little differently, it makes it very problematic in terms of translating that information and comparing apples with apples. So that, again, trying to assess either new products or new technologies, that there is some difficulty of trust with certain vendors, because when there's no laws, structure, or programs by which you can evaluate things, it just makes it more of a challenging Wild Wild West environment. So beyond that, there is this concept of problems that were identified in the study. And again, if you look at some of these issues from a few decades ago, they're still common, but through process of structured development, you can hopefully alleviate those. And some of the biggest issues that were come up with were this interest in developing a guideline or a standard. So codes and standards are really those guidelines of structure that can be used to help everyone understand the target you're shooting for and that the product you will get after it's been assessed as compliant with those requirements. So we really wanted to see that happen, but how do you get that done? Where do you go? How can you get these issues resolved? You've got the arm wrestling methodology, which that can probably work on some levels. Obviously, we can settle things in court. If someone does something, you can take them to court. That is a very expensive, long, drawn-out process that doesn't always make anyone happy. There's also poker playing, so you can do the James Bond thing and start bleeding from your eye under a high-pressure situation. I don't recommend that one either. That fourth method, that one might actually be the least frightening and dangerous, but it's probably going to involve the most paperwork and paper cuts if you're going through a standards writing or codes writing process. Or you could have Yul Brynner, throwing his Winchester, throwing some 30-06 shots there. Or, kind of working through the standards process, code process, and there's multiple entities that do this, but for the discussion today, what I was going to do is just kind of focus on how NSF has tried to develop criteria for drinking water and recreational water to really meet the needs of all the stakeholders. So the organization's been involved in standards development, conformity assessment since the 1940s, and really through use of the laboratory facilities as well as interacting with all the volunteers that help to create the consensus documents. So some of those standards in the history go back to, let's say, for the rec water environment, NSPI asked NSF to start writing standards to assess products and pool and spa equipment back in 1960. 1960 was when the first standard was issued. But from that, it's really just been a progression over time of other product types added to the scope. And then same type of situation occurred with the drinking water environment. And in that, it was really a federal program under the EPA administration that was privatized. They actually did a request for proposal, and NSF worked with American Water Works Research Foundation and other entities to create standards to assess drinking water products. And beyond that, there's also been a performance aspect, so the last program there. So how does this interaction work? The intent is really to have all stakeholders represented with an equal voting membership. So we want to have participation and knowledge of the manufacturer, really know the technology the best, but trying to have that information from the manufacturers understood in a fair process by the facility operators or the users, you might characterize that. So in this case, you could either think of it as the water utility or maybe the aquatic facility operator, the water parks operators, the pool and spa operators. And then the regulatory officials, again, they're the ones that are charged with making sure that one complies with those regulations or product requirements or facility operational requirements. So again, the stakeholders each hold a piece of a puzzle. And then what you try to do is you get, through this standards process, you get a level of agreement on some criteria. So in this case, through the NSF standards process, we have this equal voting membership for the three main stakeholder groups, and then that you have to have at least 50% of those people vote and get at least 2/3 of affirmative on a vote. But there's also the ability for people to vote negative, of course, and to have a point that would be adjudicated to essentially reconcile the negatives. So what we have actually found is that sometimes a negative is so powerful that even if the vote technically passed numerically, with 2/3 voting pass, that a negative can be considered such a serious issue that can have other people change their vote. And so that's one of the, beautiful things about the process is that it does allow that dissenting vote to be influential. Beyond the normal voting process within NSF standards, you'll also see this extra layer of public health protection. So after a ballot is passed and all the negatives have been adjudicated, which is responded to, it's not saying that every negative voter is going to be ecstatic with the response. But every negative will be addressed and investigated and responded to. But beyond that, there's an additional layer of purview or oversight, and that is through the Council of Public Health Consultants, which is different state and federal public health officials that are involved in both drinking water, food, recreational water, and other aspects of safety. So beyond that, that group has a 90% requirement for its affirmative vote before a standard can become an NSF standard. And at the closure of that process, it would be considered an ANSI standard. So for the standards process, there's a corroboration of that ANSI process. So NSF was the first standards writer to be considered an auditor designator, which is basically anytime we get done with writing a standard, it's automatically an ANSI standard. So ANSI accredits the standards process, and then there's also accreditations that NSF holds as a product certifier as well as a testing laboratory. So those things become relevant when you're developing standards. Sometimes having those capabilities enables things to happen more effectively and more completely. Now, I mentioned the area of drinking water just because it's the same products. A lot of the products that we use in our industry are the exact same products that are used in the drinking water industry. But they're just applied differently, and maybe in a controlled environment where, obviously, in our pool and spa environments, we do a lot of water recirculation. And traditionally, in a lot of the drinking water methodologies, it might be somewhat recirculated at the treatment plant, but then it's down the pipeline to the consumer end user. So there's similarities and differences. But in the case of drinking water, in that NSF standard that's used to evaluate the sort of like chemical extraction safety, that's what NSF Standard 61 scope is. It doesn't evaluate the performance of the product or its efficacy. It's just to make sure that the products in contact with water aren't contaminating that water for the consumption. So that just gives you an idea of kind of the uptake or level of acceptance it has. And then similarly, there's other international references to or acceptance of certain North American standards. But that model can really kind of contrast a little bit with what we see specifically applied for the UV products. In the area of ultraviolet light systems, there's a number of regulations just in the area of recreational water. So you've got different states that might have a certain interpretation of how they would mandate UV systems be qualified or tested. You'll also see a difference in the requirements for how they are monitored and installed. But there's essentially these 5 different criteria that we find as the major sources of evaluation and the drivers for a manufacturer to have a product tested or to help a facility operator really choose a product that's going to meet their needs and meet the needs of certain regulatory requirements. So we're all familiar with the Model Aquatic Health Code. Then there's 2 large sort of national model codes. One's promulgated by the International Code Council and another promulgated by the Uniform Plumbing Code IAPMO group. So those 2 have some similarities. They're really focused on the construction of the facility and somewhat on the operational aspects. And then in the areas of drinking water, you've got a whole other slew of criteria. And again, this kind of gets at that concept of the Byzantine market requirements or restrictions and problems. But what's helpful is when there's a way to try to translate and consolidate some of those, like find the common points of those. Well, and beyond North America, there's other criteria, specifically for the evaluation of UV systems. So I'll just mention a few of the most popular and well-known through the German organization, Austrian, as well as Norway, then the Australian and New Zealand groups. So anyway, that's a lot of information and a lot of different standards, if you will, or codes that apply to UV systems. So the goal is to really find consensus, and that's challenging, time-consuming. And let's go back to that poor lady who's trying to struggle with all the documents. If you're the manufacturer, you know that and you've kind of lived through that. Well, in the case of the standards process through NSF, we're trying to write documents that are going to be living documents, so to really incorporate current requirements, but have that document up for annual review and participation through a voluntary group to continually improve it or optimize it over time. And really that whole process is through a peer review process where anyone can bring issues to the table to update an existing document. So I mentioned again our good friends, the Byzantines, and the creation of structure or standards can be seen just as that. But through the creation of it, if it's done well, there can be great accomplishments. Now, obviously, that creates opportunities, it creates challenges, and then, to a degree, barriers as well. So the UV industry has really struggled over the years with a number of either people who just don't understand the product and technology. That's kind of an educational issue. They might be suspicious of it because of that lack of understanding and familiarity and use of it in their specific market, whether it's recreational water, wastewater, ballast water, drinking water. And then there's other applications as well, but those are the ones that I think the people in this area are most familiar with. So those target requirements for the regulatory purview or oversight, typically it was a login activation or maybe it's a reduction equivalent dose target for data and acceptance to evaluate a product. So if you're a buyer or a user of a product, you're trying to make sure you're not spending too much on a system, but you don't want to spend too little on a system that might not meet your needs, i.e. under-designed or maybe not be designed in such a way to have sufficient minimal impact on operation and maintenance costs. Because anything that you buy or use doesn't last forever. There's going to be some costs associated with that, and those are other factors that can be considered. So I mentioned NSF Standard 50, and some of you are familiar with that, but really that criteria is kind of like a 3D evaluation of a product. So the Standard 50 has some health effects criteria, corrosion resistance, design criteria. It also has microbiological disinfection efficacy requirements, what I'll call other gross kind of physical performance requirements related to burst pressure testing and things of that nature, but also incorporates claims validation and then requirements for the installation operation manual. So there's a great deal of things that are specified. And again, this kind of goes back to the Byzantine issue. That's challenging. That makes life difficult in a way for manufacturers, but it also helps you as really a facility operator or purchaser of a product know that what you're getting, if it is certified to that standard, you're actually getting a known entity or known quantity. It's not just a question mark. So this is just kind of a general scope for some of the products that are covered under the standard. But again, we'll focus just on UV systems. But within Standard 50, there was a progression as it related to UV systems. So the requirements for ultraviolet light systems really were introduced in the 1980s to NSF Standard 50, like the testing requirements. But after the Seneca Falls outbreak in 2005, that really changed the game. Everyone became more concerned about the risk presented by cryptosporidium and how can we deal with it? What were we going to do? How can we protect ourselves? And so the focus was really on some of those highest risk facilities or applications of water, the spray parks and spray pads, because of the propensity for volatilization or spraying of the water, and that really kind of knocks out a lot of that residual halogenation disinfectant. And so you're looking for a way to treat crypto, which we all know is so chlorine resistant. So there was another method that was pursued. And then beyond that, after the 2005 outbreak, there was a presentation to NSF to add crypto requirements. And that, of course, had a lot of initial resistance. So the concern was, whoa, that's a very top-heavy approach to require crypto testing for UV systems. But it was felt that for some of those high-risk facilities, maybe it's not over the top, it's not excessive, maybe it's absolutely minimally acceptable. So after a few years, we found that the Joint Committee, or the oversight group over Standard 50, said, yes, we should put this in, not make it a requirement for all things, but make it a requirement if you want to make a claim about crypto inactivation. So again, a very reasonable approach. And then part of that approach was to require testing of at least 2 worst-case models of a similar family. And I'll get into those types of details next. So within the standard, we actually put in some requirements to help guide and then also make transparent the whole process. Because again, if you're buying a product, you probably want to know, was that specific unit tested? And you want to know a little bit more about this to make sure that what you're buying and getting is actually going to deliver the performance that you need as it's been advertised or certified. So what this does, it just kind of goes over some of the details for how the products are assessed. If you have a family of products, it would be considered expensive and burdensome from a manufacturer's perspective because they're going to have to pay the cost of having a product tested, and then what happens to that cost? It's going to get passed along, of course. They can't just spend a blank check for endless testing and then that cost not go to someone or somewhere. That cost would get passed on to the facility operators, to the buyers of the product. So it's trying to strike the right balance between public health safety and protection as well as the cost impact of that cost impact of that protection. So in that, these criteria were considered some of the most important ones to factor in as far as evaluating UV systems. So let's say if they're all the same reactor type or shape. Beyond that, you would look at a simple power to flow comparison. Which one has the greatest power delivery to the lowest flow? Okay, you don't test that one because that's obviously the one that's going to pass the most easily. You look for just the opposite, the one with the lowest power to relative flow. And then beyond that, you're also looking at issues of physical parameters, pressure wall ratings, thickness, and what have you. But then other physical parameters related to the lamp type, the sensors, the control strategy, the cleaning operations. All of those factors go into the determination of which samples are utilized for testing. So we actually called that out in the standard to make it very clear what would be happening. So after determination of that worst case sample, testing occurs. And then, what type of testing or evaluation occurs? So this is just a brief summary of what's in NSF Standard 50 as it relates to UV system testing. Obviously, there's general design criteria, safety and operation protection. There's requirements for a flow metering monitoring system to be installed along with the UV system. That's not to say that you have a flow meter inside the UV system. You could do that, but it's to require the installation of that UV system with a flow monitoring device that's tied to the system. Why? UV operation is critically dependent upon, obviously, some factors such as irradiance, ultraviolet light transmissivity through the water, and then flow rate. So you need to have those parameters all monitored. But beyond that, we also have requirements for the operational instructions, the installation instructions. Really very common sense things that should be in there are called out and specified in the standard. Some of these criteria are more on what I would consider the actual testing criteria, not just documentation. So some of those criteria are the burst pressure strength, so it's really taking your manufacturer's claim for the safe working conditions and then doing a multiplier to get a higher burst pressure safety confirmation. Also doing the pressure loss testing. Anytime you have anything in the waterway, you want to know how much pumping losses there are so you can properly size the pumps and make sure you're not underdriving system and getting insufficient circulation. Beyond that, there's what we would call the operational protection, and that's a methodology to make sure that the users and personnel at the water facility aren't going to be exposed to the ultraviolet light radiation, so there's power cut systems such that if you try to remove the lamp from the system, it won't create a risk to the operators or users. And beyond that, there's additional testing, essentially this life test. So you take 3 different ultraviolet light systems and operate them for 3,000 hours, about 4.5 months. And then after that, go through performance testing on it to actually confirm the disinfection efficacy. There's also cleaning system requirements and other details. Most of the requirements that people are familiar with for UV are the fact that, yes, you are using it to do some type of a either kill or an activation of microorganisms. So this is an issue that's been discussed in detail in other presentations, but what I'll just do is briefly summarize how the products are exposed. So it's really just to make sure you can get at least a 3-log kill after this type of a dosing. But it's not just dosing the organism, it's also dosing contaminants that are more representative of a really grim kind of pool operating condition. So again, with oil and a urea content also dosed into the water makes it a very challenging test. And then beyond that, in the 2010 edition, that's where the cryptosporidium requirements were added. So some of those details I kind of alluded to earlier, but this is more like the language from the standard in terms of how you would determine the units for testing. So again, you can just kind of see that same power to flow, lamp configuration, sensors. So if a manufacturer wants to be qualified with 2 different lamp types, that separate lamp type would need to be evaluated and tested. If you want to be qualified with a separate sensor, again, critical components in the system, those would also need to be, again, tested and verified so that you as the buyer and user of the product, you're not just getting something that gives you a nice, happy, warm feeling. You know that those systems have been fully tested. So this is what we do to try to make it extremely clear and protective, keeping the playing field level and fair for all persons involved. And this is just an example of some of the details that you would see in a listing. So in this case, it's a manufacturer that has a UV system, but you'll kind of see a little listing, and then it'll get into the details of the types of performance that were evidenced by this product. And the reason being is that the test reports are very long and involved, and most people don't read them or go through them because it does have some confidential details for the manufacturer, and they're often not wanting to share that 40 or 50-page test report. What they would like to share is some of the bottom line results, and that's what we do through the NSF official listings, just try to show what that level of performance was. And for an example, it might be at a certain irradiance, a certain flow rate, you achieve a certain log in activation or disinfection. But again, beyond that, there's additional details in the test reports, but some of that is proprietary detail that a manufacturer may not want to share, but at least this content is shared through the NSF public listings. In the future, the listings will be even more defined in sort of a graphical tabular format, so it's even easier and more transparent to understand what is involved, whether it's the designation of the model, the specifics of the performance level, just kind of flow rate, the pressure rating of the system, what type of log performance or inactivation performance did that device achieve, and under what conditions. So was that at a certain level of irradiance? That way you always have to operate your system at that level of power or irradiance, the power received at the sensor. So there's 2 different things. There's power generated, that's nice, but what power is actually received and detected, i.e., is the water very low in terms of its transmissivity, so it's really preventing transmission of that light. So that irradiance factor is so critically important. You want to make sure you're operating at that power level, that power received level, and that the systems are, of course, been validated for that particular flow rate you're operating at. Beyond that, there would be other details called out as it relates to the cleaning systems. But the intent for NSF is to be more transparent and clear so you as a buyer, you as a manufacturer, you as a facility operator can more easily find what you're looking for and make sure you're actually getting that. I talked a little bit earlier about the drinking water environment and then the recreational water environment and how there's actually some overlap there. Well, the intent isn't to have the overlap be burdensome, but it's try to find a way that we can all get along and use certain requirements in a shared fashion so you don't have to duplicate efforts. Now, again, we know that some waters are recirculated, some are more one-time pass, and in the recreational water market, it's traditionally considered a recirc process, except as it relates to the spray parks and spray pads. Those are kind of considered a treat the water and then it's sprayed back out, and some people hopefully are not drinking the water because the process for that treatment is very intensive, but you're trying to provide a high level of safety and protection. So again, the cryptosporidium organism really changed the game when that hit the big city papers starting back in 2005, and then all the settlement issues that flowed from that. And you've seen different states pass regulation in their code. You'll see that type of information reflected in the Model Aquatic Health Code, which is non-mandatory, but it's meant to help people get their codes updated and be more protective so that we're doing a better job of protecting the children or those most at risk that might be using the facilities. But again, through this commonality, we're looking to have this one set of testing used to meet the needs of both groups or both stakeholder groups. Through that harmonization, the benefits will be reduced cost and faster time to market, but also greater transparency and ease of finding what you as the buyer are looking for. So in this concept, we have this framework for the evaluation and testing of the products, and that the bracketing criteria is different, though, for drinking water and rec water. Within the pool and spa program, under NSF Standard 50, we've mandated that you have to test the two worst designs. And by worst design, I don't mean that they're bad. I mean that they're slightly less power compared to the flow rate. So really, the NSF engineering and microbiological staff are taking a look at all of the samples and then trying to pick the ones that could potentially be the worst case and make sure those are tested. But the intent wasn't to test every single unit due to the large cost and concerns. However, in our drinking water program, that's exactly what we do. We test a model, and that model gets certified, so there's not a bracketing. I want to make sure that's understood, but that was kind of considered the best way to meet the needs of these different industries without creating different test standards, but really just the different applications. So essentially, you could get a product tested to one criteria, and it would meet the needs of both market groups. So again, that's kind of the concept between the crossover between NSF Standard 50 for the recreational water market and the ETV protocol, and how it's really designed to take this guidance document, which you're probably familiar with, the US EPA Disinfection Guidance Manual, last published in 2006. So that was used to create a test standard known as the ETV protocol. So again, that document didn't tell you exactly what to do, but it gave some guidance, and it was really very helpful for water facility operators that might be trying to find the right size UV system to treat their surface waters or groundwaters. Well, what NSF did is we took the guidance document and turned it into an actual testing standard, because we were finding that there's a great deal of interpretations that were applied when people were doing the drinking water testing, and it was creating differences in the marketplace. You couldn't really compare apples with apples. So it's nice to have that flexibility, but it also creates some problems for you as a buyer if you're trying to understand what you're really getting and what you're paying for. So the NSF protocol was really designed on this kind of single sensor set point approach, and then it allows the evaluation of all size of UV systems. Now, what was actually done beyond that? Again, the Disinfection Guidance Manual was just that, a guidance. It wasn't a standard. It wasn't a requirement, if you will, that says you have to do it this way. It said you could do it this way, or you could do it that way, or you could get some credits for doing something like this. So anyway, we tried to take that and put it together in a way that would create a very coherent and consistent document to really help with the evaluation program. So as part of that, there's other issues that were alluded to that needed to be addressed, either per that old AWRF research study about the problems in the marketplace when you don't have structure, but also this issue of the LT2 requirements of the long-term water treatment rule. So in there, they were also trying to come up with a way to specify certain issues and have them addressed. So one of those requirements is really just, if you're making products, how do you know that the product you're buying today that supposedly was tested 10 years ago or 5 years ago, that the product from that manufacturer today is the same or better? You want to make sure it's not been watered down. They've swapped out price. There's always price pressures. Oh, please buy this other lamp type. It's just as good as that other one. Trust us. You should use it. It's those types of issues that can only be really caught and captured and monitored and protected by auditing the manufacturing facility. Again, the manufacturers are always trying to do the right thing, but they're always getting pushed, price pressures. You as a buyer of a product, you're saying, gosh, can't I get this thing for a little less? It seems awfully expensive. So with all those pressures or commoditization pressures, it's potentially going to compromise the products. So to try to help protect against that, there's this process of the unannounced audits that are conducted, in this case by NSF, just to make sure that the manufacturer is still producing those products in the same way with the same suppliers, the same materials, the same design. Beyond that, there's, again, this concept of the validated dose. And then in our drinking water program, it's testing of each UV system for drinking water, but in rec water, to test the two worst designs in a similar family. When you think about that family, it's actually putting in some very firm boundaries and barriers, so those products are extremely similar. Again, same kind of hydraulic design, same sensors, same lamps. You put all that stuff into place, and you actually have an extremely protective system, but it's not as restrictive as drinking water. But again, that's out there as well. So the same concepts, though, you're still doing the same type of work, validating the reduction equivalent dose, and you can then take that calculated information and do different risk assessments on it. So how protective do you want to take that test result or that data? And that's something that we're able to do under the rec water program or the drinking water program. So just for a couple links to information, if you're looking for more details, again, this is on the CD, but where you can actually go and download a copy of the test plan. It's what we call a generic test plan, because you take that document and you actually customize it and put in the specific flow rates and conditions for different UV systems. But the idea is you're performing that one-time testing and publishing a test report, publishing a listing, and then there's ongoing conformity assessment audits to make sure that that product will still continue to perform at that level over time. Talk more about the rec water area and the drinking water area. The intent is that, again, the same concern that a one-time test might not be enough. How do you monitor for change over time? The ongoing verification. What if a manufacturer, wants to make a change? They'd say, gosh, I think this is a better sensor. Well, the program would allow for the evaluation and or testing to corroborate that. So again, the buyers or the users of the product make sure they're getting a product that performs well over time. It allows for ongoing development of those products, for improvement of those products. And in this case, again, through the testing program, the changes are reviewed prior to authorization. So again, if a manufacturer does want to make a change, that can be done, but there's a process for doing so. So it's not kind of a hit and miss, willy-nilly process. As it relates to the ETV program, that protocol was really developed to take the old disinfection guidance manual, the 2006 document, that again hasn't been modified or changed since then, but there's been a lot of research that has caused the industry to say, time is slipping by here on this document, and we've learned some new things about certain organisms that were used for testing that we might need to protect for a little differently, i.e. safety factors. So because of that, there's more and more pressure to revise that older document, the EPA Disinfection Guidance Manual. So what we did is, again, we created a test plan by working with state drinking water authorities as well as manufacturers to get their input. And then that is being transitioned over to a standard. So instead of it being just a kind of protocol that's a single one-off, to make it an ongoing living document so that as changes are detected in the industry, those can be incorporated. So in summary, I just wanted to note the concepts of the struggle, if you will, to comply with requirements, to develop those requirements in such a way that they're going to be coherent, applied consistently, and then to benefit the users of the products and the industry for public health protection. But again, you can kind of see more information on the NSF website, but this concept of certification is ongoing conformity assessment. It's not just a one-time, one-off deal. Thank you very much. If you have any questions, let me know. But beyond that, there's other information about drinking water system testing and validation. I won't go through all of that right here, but if you open up your CD in your room, you'll get more details on this. I'll just kind of flick through it. But it's how we go through the actual radiometer testing, the UV sensor evaluation, and other work. It's kind of a more detailed PowerPoint presentation, but again, that information is available to you on your CD. Do you have any questions? Yes. The question was that because of the, I guess, complexity as it relates to some of the UV system products and how they're evaluated and the level of power or performance that's applied, that is creating some challenges that people can't just look and say, oh, great, it's got a mark, it's certified. No, there's a little more to it because with that product, there's different conditions under which it can be used and meet certain requirements or affect a certain log kill. Yeah, there's some kind of analogous situations to that. When filters are certified, they're not just, it's a certified filter. It's certified for a certain flow rates. It has a certain amount of surface area. So there's certain physical parameters of the product, and then there's also the tested performance. So there's design criteria. Same thing with like chemical feeders. So when we test and certify a chemical feeder, okay, there's all those health, safety, performance issues, but then you get into some quantitative examples of that. For chemical feeder X, how much does it really put out over unit time? Well, that's one of those critical numbers you need to know. So it's good to know it's certified, but what can it put out? Well, that helps me size the number of systems I either need to buy for that size of the pool based on how many users are in the pool, the volume of the pool, the circulation rates. So it's similar and different. But there are kind of other examples like that. But that's what we're really trying to do is just quantify the really critically important parts, make it easy for you to go and find that information without having to call up the manufacturer and get their test report and then go through that 50-page test report and make sense of it yourself. Good question. Because of that, and I'll just kind of repeat the question. The question was, because of the 2010 change to Standard 50 incorporating a testing requirements and evaluation requirements for cryptosporidium, does that somehow remove or supersede the requirements that have been in the standard for years, the 3-log kill for Pseudomonas and Enterococcus? No, it doesn't. But here's how we have looked at it, really based on how the industry has looked at it as well. The existing infrastructure of the products being tested and being certified for a certain performance level is still relevant, but the issue is that some use or application of UV systems, you might want even a higher level of performance to be verified. So especially in the area of spray pads or things where it's more likely that you're going to destroy the halogen or the residual disinfectants, and that the only thing you really have to fight against the cryptosporidium is some other methodology, typically UV or ozone or some other kind of methodology. So that's still in there, and there's not a goal to remove the traditional tests. There has been talk about it, though, like, hey, if you do the crypto test, you still need to do the other test. I could see someone making a proposal to the Joint Committee to change that and then doing some parallel testing to show when we ran a system that achieved this much crypto kill, or inactivation, sorry, that it's the equivalent of this much kill of Pseudomonas and Enterococcus. Okay, if that was done, that would be sufficient justification to remove that for those products that are tested. Okay? Yes?
Best case, worst case with UV, is turbidity part of the measurement mechanism for evaluating its efficacy?
Well, during the testing, turbidity is relevant because it's, the question was, is turbidity part of the evaluation criteria for the performance testing of UV systems? Yes, it is, but we don't calculate it based on turbidity alone. It's really this concept of the UV transmissivity. So turbidity can be problematic and challenging, of course, for light to get through the water and actually get to that organism or that material and have an effect. But what we're using when we're trying to describe the disinfection properties or the kill properties is we use this other term of the UV transmissivity of the water. So that is part of the testing program to test at different UV transmissivities. And you do that to make sure that you can still function and provide a certain level of irradiance. That's a quantitative value, essentially like a power value. But that then translates, okay, if the system is running with this irradiance and it generated 3-log kill or a 40 millijoule reduction equivalent dose, those are some of the variables you need to make sure that you as an operator then are getting that same level of irradiance at those flow rates, and then you're assured that you're getting that 3 log or 40 millijoule type reduction equivalent dose. I don't know if I made that clear, but turbidity is relevant, but we actually use the UVT to monitor and test for it because it's actually more all-inclusive. You can actually have very non-turbid water but have terrible light transmissivity due to oils and other materials that are light diffracting as well. But they just don't look cloudy, but the light can't get through it. Right, there's some of the, thank you. The question was about biofilm production and how that can make transmission of the light problematic. Basically, if you have a biofilm-coated surface, I think, was that the issue, that biofilms can prevent transmission? Okay, so the issue is if biofilms, which of course can cloud or occlude and prevent transmission of the light, yes, you won't be able to achieve that same level of treatment and disinfection. So some UV systems have either manual wiper systems or automated wiper systems. And several slides ago, here, what we're looking to do is actually specify those, with the cleaning system. What is the UV system? Is it low pressure, medium pressure? And those are, basic indicators of, in some ways, performance or energy consumption, but also the potential need. If you got a really hot medium pressure system, you might have more buildup of either scale or biofilm. It's not that it's directly correlated, but the biofilm will definitely impact transmission. So you're looking at irradiance, which isn't how much power you're putting out, but how much power is received at a sensor. So you got a light lamp over here, a sensor over here. If you're getting the right power over here, that would roughly indicate that you don't have a biofilm problem because you're getting sufficient transmission. But biofilm buildup can be indicated by low irradiance. So again, some people try to have a manual wiper to clean off their lamps and help prevent biofilm becoming a problem. Okay, thank you.